Hi, I'd like to introduce today Thibault, who's going to be speaking about an infrastructure without secrets and a nightmare for attackers. So Thibault, if you want to introduce yourself and take the stage.
Good morning, everybody. So I'm Thibault. I'm a French engineer. I've been pen testing companies for 4 years, and after I've joined Paddock, and I'm glad to be here today. Should I start?
Yes, of course. Sorry.
Okay.
Yeah, you should have full control.
Okay. So welcome, everybody. I hope you will like this presentation. I'd like to talk to zero credentials infrastructures. It's a concept that we have developed at Paddock, and it's working very efficiently to prevent attackers from being interested in your infrastructure. So just a quick word about Paddock. Paddock is part of Thibault Group. It's a French company. We address all sorts of technological problems, and at Paddock we're focused on DevOps, cloud, and cybersecurity, and I'm responsible for the security services. Okay, so we will start with explaining what is a zero credential infrastructure and how to remove every long-term credentials from your infrastructure. So we will start with developer secrets, every secret that's used by humans, CI/CD secrets, more importantly, the workload secrets, and after we will talk a little bit about non-regression and conclusion. And there will be some technical demos, so don't fall asleep before I start the demos. Okay, so if we take a step back, secret management has always been a problem. Since secret exists, it's been a problem. How to manage it, how to make rotations, who is using secrets, when. It's a pain for everybody. And it causes security problems too. For example, in January, Mercedes has leaked some source code after exposure of a GitHub token. So it was a simple human mistake, and all the security that has been built by Mercedes crashed instantly, and all the source code of Mercedes-Benz was leaked. And more recently, in February, an ex-employee's admin credentials for a US government was leaked and used for an attack. We don't know yet the blast radius of this attack, but it's a major one. So even big companies have problems resolving this secrets management thing. There are also some reports, very recent reports from Verizon and Google Threat. They all say that most cyber attack involves a human. Maybe it's social engineering or it's just an error. And also credentials continue to be involved in attacks. So it's not me that is saying it. And also Datadog has said that secrets rotation is not a good thing in here. We can see that in AWS, Google Cloud, and Azure, there are lots of long-lived credentials. And these cloud credentials are extremely important because as the API of the cloud provider is always public, if someone finds these credentials, he will be able to connect to your infrastructure and do a lot of damages. So in the past years, some tools have popped up and they are acting after a secret is created or leaked. The most well-known is Git Guardian. They will tell you if you have leaked a secret in your source code. So sometimes it's after the secret is created or leaked, and Cyber Engine is monitoring if your secret is somewhere on the dark web. With zero credentials infrastructure, we will try to eradicate the source of the problem by removing any long-term credentials. So this is the paradigm. So what does it change? On the left, you have legacy concepts, and on the right, zero credentials. So nowadays, developers still have many passwords to handle. And with zero credentials, we will try to switch it with a single sign-on. This is something that most of you have normally already done. It's the first step of zero credential infrastructure. We will try to replace authentication by authorization, secrets with tokens, avoid any manual rotation with refresh tokens, and try to generate on-the-fly credential when it's needed, instead of storing it in a long-term fashion. And even if awareness for developers is still something important, if you have a lot of mechanisms that implement security by design, you will avoid most human errors, even if they are aware of security problems and that it's important. So what are the benefits of a zero credential infrastructure? First, it will reduce the risk of attacks by approximately 60%, because 60% of the attacks involves long-term credentials. In the kill chain of an attack, first, an attacker will take control of part of your infrastructure, get credentials, and he will try to resell it to another malicious attacker who will do some threats in ransomware, cryptojacking, everything. So if the credentials are short-lived, an attacker cannot resell it to another one. So it will make you a less interesting target. Also, you have to consider the fact that most attackers, they are looking for the low-hanging fruit in the environment. And so they will look for the less secure companies. If you have done some efforts to secure your infrastructure, you may avoid a lot of attackers' attention. And also, we will dig this deeper in the following of this presentation, but with short-lived credentials, everything is automated, so an attacker will have to go through the same path a developer does to do production release or anything. It will leave traces in the logs, and attackers don't like it. On the developer side, it makes the developer experience much better. We have seen it in the project that we have done. The developers are very happy with zero credentials infrastructure because they will have only one password to enter at the beginning of the day. They won't have to do anything related to secrets. Everything will be automated. They won't have to handle rotation also. And they will strictly keep to what developers does best, is writing code. And the configuration will be handled by automated process. And lastly, for security teams, it's a huge improvement. You will have a lot of compliance by design. Every compliance step related to password management, creation, rotation, everything will be done by design. It will greatly improve also the auditability of your infra, because as credentials are generated on the fly when it's needed, in the logs you can see that this credential was generated for this task for 15 minutes, and that's it. So it's much better than having a password shared by a whole team of developers. It facilitates also onboarding and offboarding. You just have to create one access on the single sign-on and give permission, and that's it. And we've seen it a lot also at Paddock. When someone is attacked, there is a lot of stress generated, and with zero credentials, it simplifies the emergency procedure, because you know that if you have fixed the vulnerabilities the attackers used to enter your infra, you just have to wait 15 minutes and you won't have any credentials anymore to use. So I hope this is clear. Do not hesitate to ask questions in the tab. I will have some time at the end to answer it. So where are credentials stored in an infrastructure? This is a very simplified schema just for me to be able to show where credentials are stored most of the time. On the employees workstation, you will have the password manager, some text files, the history files of Slack, Teams. Everyone once a month, or it depends, but it will share credentials when it's when he has to rush, when something is needed very quickly, he will send credentials through Slack, Teams, any messaging app. On the CI/CD, they are mainly stored in the code base. This is a very bad practice, but we still see it nowadays. Or it is stored as CI/CD secrets, so the CI/CD is able to deploy any assets to the infrastructure. And on the infrastructure itself, for example, cloud infrastructure, it will be stored in the secret managers software, and it will be also stored in the runtime environment, in the virtual machine, containers, serverless function, anything. In storage bucket also. So you have lots of credentials stored in many places, and sometimes there is some replay of credentials. It's a very common pattern to see developers use credentials that are used by machines in the development environment to connect to database, or even production environment. So at the end, you don't know when an access is made on the database, who has done the initial access. Is it your runtime environment? Is it your developers? You don't know. So the method that we have developed to reduce these long-term credentials is in 5 easy steps. First is detection. Just map every secret that you can find, define by who it is used, and after you will be able to eradicate it. And we will reduce the developer secrets, the CI/CD secrets, the workload secrets, and after there are some useful steps that you can do to avoid regression. So let's start with the developer secrets. As I said earlier, this step may have already been done by you, connected the single sign-on. Before single sign-on, you had to have credentials for each asset you want to connect to. A web application, cloud infrastructure, Active Directory, any internal web app, internal tooling. With SSO, you only have one identity provider that is federating your identity and allowing you to connect to different things like web application, infra, everything. Just a quick note, it's very useful to enforce your MFA on your single sign-on. As it's the main point to connect to everything, this became some critical assets and must be handled very carefully, of course. So when we do this kind of mission for our clients, we have some objections. I have a custom application. It doesn't support SSO. For example, it's my main product in the development environment. I don't want to configure anything else that is not in production, so I cannot connect to it through SSO. Sometimes you have tools that you don't pay for the license, and there is this SSO tax things with lots of tools, so if you don't pay, you cannot connect your company SSO to the tool. And sometimes you said, but it's a pain, but my database, for example, my MySQL database doesn't support SSO, and so I cannot plug SSO to it. Fortunately, there are some solutions that exist to address these issues. First is a product that I like a lot. It's an open source product. It's called OAuth2 Proxy. It allows you to act as a reverse proxy in front of your web applications, connect to your identity provider, so you can add a layer of authentication and avoid expose your internal tooling or your developer applications, development environment application, sorry, for everyone. You can just put your OAuth2 proxy in front of it and use SSO to add a layer of security. Another good solution is to have a Bayesian host. I like the setup with HashiCorp, Boundary, and Vault. It allows you also with open source tools to plug to your identity provider and access all sorts of assets that are not supporting single sign-on natively. Kubernetes clusters, SSH key to connect to VMs, database credentials. So with OO2 proxy and boundary, you will be able to address most of the assets that does not natively support SSO. It will remain, unfortunately, the SSO, the SaaS application that you are not paying for SSO. But you will have reduced the number of credentials to the minimum you can have. Okay, so this was the easy part, developer secret. Now we can talk about CI/CD secrets. This is also not so complicated, but I see that in most companies that I go to, if the developer secret has been handled, the CI/CD secret is not something like I see usually, even if it's very easy to set up. So 2 parts for the CI/CD secret. First is the secrets in the source code. So how to have 0 secrets in your source code. First thing is to be sure that you don't have secrets. You may have some surprises. And it's a good thing to try to detect, scan all your repositories and see if you have some clear text secrets. There are 2 open source tools that are well known. It's Trufflehog and GitLeaks. At Paddock, we have created a tool that mix both tools, so it takes the best of both tools to scan your repositories and output an Excel files with every alert that has been triggered. Sometimes it's false positive, of course, but it allows you to automatically scan everything in your GitHub or GitLab organization. So please use it if you have some issues to tell us or some remarks. It's welcome. After you have detected all your secrets, what do you do? So these secrets must be gone. They must be moved to a secret manager, to a vault, to anything that's more secure. And if you cannot avoid storing it in the code base for whatever reason, maybe you are deploying to a system that is disconnected from your infrastructure, that doesn't have access to your vault or your secret manager. In that case, you can use SOPs. It's a Mozilla product, open source also, that allows you to store encrypted files and to decrypt it at runtime. I will show you this just after. If you are rotating these credentials, ensure each credentials has a unique usage. For example, if you have a bunch of microservices and you realize each microservices use the same password to connect to the database, it's a good time to create a unique credentials for each microservice. And of course, all the clear text secrets that has been found must be rotated because they may have already leaked and maybe you don't know about it. So SOPs, how is it working? A developer has the clear text configuration and he is able to encrypt it using any key solution management services and push the encrypted version in the GitLab or GitHub repository. And it will be decrypted when it's deployed on the workload. So you allow developers to encrypt and you allow your workload to decrypt it. And at least you don't have clear text credentials in your code base. How to decrypt it? You can use an init container. You can use a job that runs before your application. It's not so complicated to implement. Okay, so that was for secrets in the code base. Now let's talk about secrets, the CI/CD secrets itself. So a lot of major investments have been done in the past few years. It's now possible to allow a repository or a branch to connect to your cloud infrastructure or to your Active Directory infrastructure without having credentials, just relying on authorization. So first step is you will create an OIDC trust. So on your infra, you will trust GitHub or GitLab or anything Bitbucket to connect to your infrastructure. And whenever a repository, for example, repo A, will try to connect, it will first generate a GWT. It will present it to the cloud infrastructure. If it's allowed, if it has been allowed in the policy to connect, after the GWT has been verified, you will be able to get short-term credentials to connect and interact with your infrastructure to deploy things, push a Docker container, access a database, connect to a Kubernetes cluster, whatever. So I will show you how it works. So this is Terraform code that I've been using to create this OIDC trust. So here we create a trust in AWS. This is just an example, but we will trust GitHub. After, we will create a dedicated role for my GitHub repository, and I will allow it to be assumed by who? By the GitHub organization called Paddock team, and only this repository called demo GitHub action OIDC, and only the main branch will be able to assume it. So this is a great improvement. Before, you had some secrets in your repositories, and anyone able to trigger the CI/CD will be able to print these secrets, to export it, or to use it maliciously. Now, you know that only the main branch will be able to access your production environment. So if you have a protected branch, if you have a 2 eyes review or anything, you know that nobody will be able to access it directly. And each time a new credentials will be created, because each time this role will be assumed, credentials will be created, and each run of your CI/CD will have dedicated credentials. So I will just allow the role to list a S3 bucket, for example, and I attach it to the role. So that's it. You just have to create your identity and to allow your identity to be used by a repository or a branch. And so if I use it in my CI/CD, what will I do? I will first allow my repository to create a GWT. And after, instead of using hard-coded credentials, I will just say, okay, this is the role you need to assume. And after, you will be able to use it. And I can configure how long a credentials is available. So I will show you right away. I will create a reverse shell inside the GitHub worker to show you concretely how it works. So I will just push to the repository. Okay, so that's it. I've pushed. And as every commit on main branch will trigger this job, normally I can go to GitHub and see how it works. So the job has been triggered. So the worker will create a GWT, present it to AWS. AWS will check that the GWT has been signed by GitHub. After, it will check in its identity and access management if this repository and the main branch is allowed to assume the role, and after it will work by design. So I may have some issue with the running action. I will get back to this tab after the job has been run. Okay, just be patient. It will it will work eventually. Okay. So what are the objections for this CI/CD secrets replacement? Clients tell me my pipeline, the assets my pipeline is accessing are not connected to Cloud IAM, so it doesn't work. Even if my pipeline is able to access credentials, it's not useful to access my database, for example. Or it requires some external credentials that cannot be generated in the flow. So what do we do when we have these problems? Possible solution is at least to use this OIDC mechanism so your workload access some remote storage, a secret manager or a vault to retrieve secrets. Why should we do that? Why add another step? Instead of storing the secrets, store it elsewhere and authorizing your repository to access the secrets. It's better because you will store your secrets in one place. You won't have two places where your secrets will be stored. It will be easier to do rotation. And if an attacker wants to use it, he will have to leave traces in the CI/CD pipeline. Another good point is, we will see it after, is if you can use dynamic secrets, for example, for database, it's possible for Vault to generate secrets every time someone wants to access the credentials. It will be better than nothing. Each time a repository wants to access a database, it will connect to the cloud, ask Vault, and have one-time credentials to connect to the database. So last part, let's talk about workload secrets. In the meantime, I will just check if the job has been run. It's a shame it's not running. I will just check my previous job if it's possible to access the worker, but I don't think so. But in the previous job I just launched before the presentation, I tried to access AWS. Oh no, it's not working. Maybe I have some connectivity issue. I will just wait for this job to be launched. Okay, let's talk about workload secrets. So this is a much more complicated thing to do. What you need to consider is it will have some friction with your application. When you try to have automated rotation, it will not be as easy as CI/CD or developer secrets. So you have to ask yourselves, what is the type of workload? How do applications load secrets? This is a very important question. Is it through a file, an environment variables? Is it directly accessing some vault or some secret managers? Is your application compatible with some mechanism? For example, in AWS, GCP, or Azure, you can authorize an application to access a database directly through IAM. But sometimes you will use libraries that are not compatible with it. So this is some important questions. And last, what type of secret is it? Is it an asset that is stored on cloud and that supports IAM connections? Is it some assets that are supported by Vault dynamic secrets? Is it a simple API key that I cannot rotate easily? These are the important questions. In the following of this presentation, I would like to zoom on various Vault Kubernetes setup that are useful to do this automatic rotation of credentials. But of course, a lot of solutions exist, and I invite you to contact me if you want to discuss further your particular use case. I will be happy to discuss it with you. So the first setup that we can see is using Vault as a backend and using external secrets in Kubernetes to get these secrets. So in each of your Kubernetes namespace, you will use external secrets to connect to a secret store that is connected to Vault. So each time your application wants to use a secret, this secret is automatically synchronized by external secrets. So if you do some rotation in Vault, external secrets will detect it, and it will reload the secret object in Kubernetes. But you will have to roll out your application yourself, so they take into account that the secret has changed. Otherwise, it will just keep using the old secrets, and it won't work anymore. So this is a nice and easy setup. Another setup that is provided by Vault is the secret operator. So it's an agent, an operator that will automatically synchronize secrets, just as external secrets does. It's slightly better because the Vault secret operator is able to automatically roll out application whenever a secret is rotated. So it will detect this rotation and roll out your deployment. If you have multiple occurrences of your application, the old ones will still have active connections with the old password, it still works, and the new ones will start using the new credentials. So this is working nicely. The only problem is that it is using a secret object, just as external secrets. So the granularity of your secret is a deployment. Every pod of your deployment will use the same secret. Another solution is the CSI provider. So it works a little bit like the operator, but this time the Vault will create a mount on your volume, on your deployment, on your pod, and store credentials in it. So if your application just needs some secrets in its file systems to load, this is working nicely. But it does not support secret rotation. So if the secrets changes in Vault, the CSI provider will not create a new volume. It's not possible, of course, because it is already mounted on the pod, and that's it. So you will have to handle rotation too. And another setup that I will show you with a technical demo is this one. I like it very much. It's to use the Vault agent. So a Vault agent will create an init container in each of your pods. I will show you concretely how it works. And the nice thing is that each pod will get a dynamic credentials, because your Vault agent will try to read a path in Vault, for example, /database /creds /read only. And if it's a dynamic secret, Vault will generate the secrets on the fly in the database. So each of your pods will have different credentials. And it makes auditability much better, because you will know which pod has done what on your database. The only problem is that the Vault agent will create a file on your pod, so you will need to develop a library to watch the file system, for example, with iNotify system calls, and to reload the connection to the database, for example, whenever the credential is rotated. This is a QR code that links to HashiCorp blog, where they talk about these different solutions. I was not able to speak to every pros and cons here, because our time is limited, but you can go by yourself and check it out. All right, so let's do a demo. I will just check if this job is done or not. No, it's not. So it's demo effect. Sorry for that. So let's talk about Vault and the Vault agent. So I have created a local Kubernetes clusters, and I will create first a database. So we'll create a PostgreSQL database. So I've created a namespace, and I've created a deployment for a Postgre. and there is still a demo effect. What's happening? I need to delete this persistent volume. I'm sorry for that. Just do it back. Okay. So this time the PostgreSQL database is creating. After, I will create a vault and I will connect everything and push a demo application so you can see it in action. So now I will execute a shell in the PostgreSQL pod and I will connect to the database. So here I am. I need to create long-term credentials for Vault. This is the only long-term credentials that will be created in the database, and Vault will use it to create short-lived credentials. As a note, it's possible to automatically rotate this password, but I won't have time to show it to you today. So now I will create a role for Vault, and I will create also a role for my applications, just for the demo, a read-only role. So Vault will be super admin, and it will have access to a read-only role that it will use to create short-lived credentials for my applications. So I can go back here and create the Vault. So I will install Vault. Okay, so normally I should have the Vault here and the agent, the Vault agent. So I will execute a shell in the Vault pod, and now I will be able to create the path for database secrets. So I will enable the secret engine called database, and I will create one configuration here. So let me expose it to you. So I want to connect to a PostgreSQL database. I will use my long-term Vault credentials to connect to it. So Vault will be able to interact with the database. And now I will create the dynamic secret. So what I will do, I will create a path called database/roles/read-only, and anytime someone will try to access this Vault path, it will execute this SQL sentence. So it will create a dynamic short-term role with a custom password for a certain amount of time, which is here 1 hour. So I will create this file, and after I will use it to create my path to Vault. Okay, so let's check it how it works. If I try to read this path, I will get for 1 hour this username and this password. It's been created automatically. If I do it again, I get different credentials. And I can do it anytime I want. It doesn't mean that this one is not available anymore. I've just created 2 new credentials for the database for 1 hour. Now, how do I connect my Kubernetes application? How do I do this interaction between the application and Vault? I will allow Kubernetes authentication, and I will connect Vault to Kubernetes, and I will just say, okay, this is the policy. Someone will be able to read this path, and I will say who will be able. I will allow the service account name internal app in the namespace default. So I will just create this policy. I think I've just missed something. Okay. Okay. So now I can deploy an application, and if it's default namespace and if it's using the internal app, it will be able to have access to this path, the read-only path. And whenever it accesses it, it will execute this SQL statement and generate a new credentials for it. So I will deploy a simple 3-pod application. Okay. So I will restart it. I don't remember how to do that, unfortunately. Okay, so these are freshly new pods. And if we check the logs of the cube of the Vault agent, you can see that the Vault agent has detected that some application needed Vault secrets. So this is something I have not shown you, but here in the deployment of the application, I've created some annotation. I said, okay, can you inject credentials? Can you use the role internal app? And can you access this path in the Vault? So when the application started, the Vault agent created an init container and mapped the credentials returned by Vault here to the application. And so now, if I checked what credentials have been loaded in the application for the 3 pods, I can see that each pod has a different login. So it's not so complicated to set up. And after you know that all your pods will have different credentials and that the Vault agent will be responsible to reload it frequently, you just need to code a small development library that watch the file where the credentials are stored and notifies the application to reload the database credentials connection. Okay. So this is it for workload secrets. Again, there are a lot of configurations possible, lots of interaction with applications. So I've just shown you some examples, but lots of solutions are available to you. Even if each ecosystem is different, you can ask yourself, can I use authorization instead of authentication? If you use cloud assets, normally you can just give IAM roles to your application to be able to connect to it. Does my asset support dynamic secrets? Is Vault able to generate SSH key on the fly, Kubernetes authentication, database credentials? They have a lot of supports for dynamic credentials, so check it out. And finally, for other assets, how can I implement automatic rotation? If it's a third-party API key, maybe you will be able to just do some API calls to rotate the API key. So finally, zero-code infrastructure, it should boil down to 1 secret per person, 0 secrets in CI/CD, and 0 secrets at runtime, which will avoid human errors and force the attackers to leave traces. Okay, thanks for listening to me. If you have any questions, you can ask it here, and I have my LinkedIn here on the right if you want to chat with me after the talk. Okay, so there may not be any questions. Please contact me on LinkedIn. I will be happy to discuss particular use cases with you, and enjoy the rest of your CyberWise conference. Too bad for the first demo. Still no questions in the chat.